Hello all. Today we are going to discuss about round robin scheduling algorithms. So usually round robin scheduling algorithms they used to ask like problems, that is problem will be like this: calculate the average waiting time, or they may ask like calculate the average turnaround time by drawing a NAT chart using round robin scheduling algorithms. So usually round robin scheduling algorithms usually using in multitasking or time sharing operating system. So what is a multitasking or time sharing operating system? Already we have discussed when we discussed different types of operating system. So when you are using your system parallelly, you will be doing multitasking, right? You will be browsing something on your browser. Parallelly, you can open a Word document and you can write something on your Word document. Parallelly, you can play a video and you can watch some movie, right? So actually what is happening, you are doing multitasking, but at that particular time CPU is not executing all the process at that same time. It is not true. Actually what is happening is at any particular instance of time CPU will be going to execute only one process. But what is happening is in time sharing or multitasking system, a time quantum will be there. Within that particular time quantum, CPU will be keep on switching from one process to another process, so that user will be having a feeling that CPU is doing the multitasking operation. Okay, so round robin scheduling algorithms are in the mode of preemptive scheduling algorithms. That is, it is not mandatory that if a process has allocated to the CPU and it has to complete its execution and CPU has to switch to the another process. It is not like that. Preemptive scheduling algorithm means in between any time process, CPU can switch to another process. So here in round robin scheduling algorithm, in the question itself, they used to give a time quantum time also to calculate. Okay, and this type of scheduling algorithms will give you best response time when you are comparing to other scheduling algorithms. So here in these type of questions, they used to give this table in your question. That is, the table will contain process, arrival time, and burst time. And for this round robin scheduling algorithm, in the question also they used to give a time quantum. Here we are setting a time quantum as a time quantum of 3. Suppose we are taking a time quantum 3, we are guessing. Okay, t time quantum 3 unit we are taking. Usually in the question itself they used to give a time quantum. Okay, so process, arrival time, and burst time. Arrival time, no, you know what is an arrival time? That is what time, what particular time that particular process has entered in the ready queue. Okay, process has to first insert it into the ready queue. From the ready queue only process will be going to allocate to the CPU. Okay, so the stop this particular table is your NAT chart, and this in this particular round robin scheduling algorithm, it is recommended to create parallelly to draw a ready queue. Okay, to remove the confusion. Okay, to avoid the confusion, parallelly it is suggested to maintain a ready queue. So this is your ready queue. Okay, so this is your ready queue and this is your NAT chart. This is your NAT chart and this is your ready queue. Okay, first process will be going to insert into the ready queue, and from the ready queue it will be going to allocate to the CPU. That is nothing but in the NAT chart. So first, at arrival time 0, we have to see starting from the arrival time, starting time. So at arrival time 0, you can see that for process P1, arrival time is 0. So first process, it will be going to insert into a ready queue as process P1. So P1 will be going to insert into the ready queue means at time 0. So at this particular time 0, only process available in the ready queue is P1. So that process is allocating to the CPU. That is, it has to insert in your NAT chart. That is, in the NAT chart, whatever inserting is nothing but that particular process is executing by the CPU at that time. So at time 0, you can see that in the NAT chart, process P1 is going to execute. Okay, and I have told in this particular problem our time quantum is 3 unit of time. Okay, so 3 unit of time, that unit of time quantum they will be going to give in your question. So it has to execute that particular 3 unit of time, and parallelly you have to see its burst time also, whether it is less than 3 means no need of executing 3 unit of time. Okay, see here in this case process P2 is having only 2, so no need of executing till 3. Okay, so for process P1 anyway burst time is 8 unit of time is, so out of 8 it will be going to execute 3 unit of time, then it will be switching to another process. Okay, that is actually, it is like a circular cube. Okay, it will be going to switch from one process to another process with a time gap of 3 unit of time. So so at time 3 it will be going to execute. So it 3 time 3 you can see that. So at time 3 it has executed. So out of 8 you have to reduce 3 unit of time. So process P1 burst time is 8, right? So 8 minus 3, remaining burst time of P1 is what? 5. 8 minus 3. So 3 executed. So 8 minus 3, remaining burst time of P1 is 5. Okay, and that particular time 3, before 3 we have to see any other process has come or not, or any other process has arrived in the ready queue or not. So you can see that after 0 at time 1 process P3 has arrived. Okay, so here in this ready queue already P1 has allocated, right? So you have to remove that particular P1 here from the ready queue, because already it has allocated to the NAT chart, right? Next, or none allocated to the CPU. Next, at time 1 P3 has inserted into the ready queue. Here you can see that process P3 has inserted into the ready queue at time 1, and after time 1 you are having 5. Okay, so before 5 here we are at time 3, CPU is at time 3. So once it is completed 3 unit of time, again what is going to happen is this P1 will be going to come back to your ready queue here, because still it has to complete 5 unit of time. Process P1 has to complete 5 unit of time. So once it is completing 3 units, CPU has to switch to another process. So P1 again it is coming back to your ready queue here. Okay, now next, which process is first in your ready queue? P3 is your first process in your ready queue. So next it will be going to allocate at time 3 process P3. So you have to remove process P3 from your ready queue, and it is going to allocate to the CPU, that is process P3 at time 3. Again it will be going to execute 3 more units, because process P3 burst time is 7. Okay, so it has to execute 3 more units since our time quantum is 3. So it is executing till 6. So 3 unit it has executed from 7. So 7 minus 3 it is 4. So remaining burst time of P3 is 4. Okay, now we have to see within before this particular 6th unit of time or 6th time any other process has arrived or not. Yes, it has. At time 5 process P2 has arrived, right? So you can see that process P2 has inserted here in the ready queue. Okay, and then you can see that at process 4. So now CPU, that particular process P3 completed at time 6. So at time particular 6, P3 has to come back to your ready queue, because still P3 has to complete 4 unit of time, and at currently we are at time 6. So at particular 6, P3 has to come back to the ready queue, and P4 also at time 6 it is going to arrive into the ready queue. Okay, so both P3 and P4 now arrival time is 6. Now then which one to insert first in the ready queue is whichever the process is new to the ready queue, that will be going to insert first. Here P4 is the new process that is coming into the ready queue. So we will be going to insert P4, then we are going to insert P3, right? So now P3 and P6 is having same time 6. Okay, it has to insert into the ready queue. Which one we will be going to insert? Newly arrived process. P3 already executed, so it is not new. P4, but it is new. So P4 it will be inserted first, then P3 it will be going to insert. See, P3 we are inserted here. So it is one, this is actually one ready queue. This is actually one ready queue. Okay, here P3 we have inserted. Now at time 6. Okay, so now we are in CPU is now 6, which next from the starting ready queue, which is the first starting process. CPU here, starting process, here it is P1. See, here in the ready queue, P1 is the next process. So P1 it will be going to take from the ready queue and going to allocate to the process or CPU. Okay, so next CPU will be going to execute process P1 at time 6. Okay, again CPU will be going to execute it 3 more unit. Okay, so 3 more unit. It is not mandatory that every time it will be, if it is less burst time months, it will be executing that particular time. Here you can see that P1 still it need for 5 more unit, till it need 5 more unit to see process P1, it need 5 more unit to complete. So from 6 it will do how much unit of time? 3, because our time quantum is 3. So 6 plus 3 till 9 it will be going to execute process P1. Okay, and from here you have to process P1 burst time, process P1 burst time, again it will be going to reduce 3 unit of time. So 5 minus 3 pending time for you burst time is 2. Okay, then at time 9 again it has stopped that particular process and P1 has to come back to the ready queue. Before inserting P1 to the ready queue, you have to see before time 9 some process has entered in the ready queue or not. Yes, at time 8, see here, at time 8 process P5 has entered in the ready queue, right? So P5 has entered into the ready queue, then P1 is coming back to your ready queue here. Okay, now at time 9, which is our first process in your ready queue, P2. So now we will be going to allocate P2 to the ready queue, P2 from the ready queue to the CPU. Okay, so from 9 it is going to execute C process P2. Okay, P2 from the ready queue and allocating to the CPU. Okay, so again P2 it will be going to execute. So actually it is supposed to execute 3 quantum of time, but here you see process P2 is having only the burst time, it is 2. So it will be going to CPU will be going to execute only 2 unit of time, because only 2 unit of time is needed to complete process P2. So 9 plus 2 11, till 11 it will be going to complete process P2. Okay, so process P2 has completed its execution. Okay, so once it has completed execution means now no need to come back to the ready queue. That process itself is going to exit from the scene. Okay, next, so at 11, so at this, from this particular time again no need to check in your this one, you are ready queue, some process has newly arrived or not. You can see that all the process has entered, right? All the process has entered and it is in the ready queue, right? So now from here time onwards no need to check whether any process has came or not before this particular time, right? Now so we are at 11, what is the process, starting process in your ready queue? That only we need to check, because all the process has arrived in your ready queue till 5. Okay, so at time 11, what is the first process in your ready queue? P4, right? So P4 is going to take from the ready queue and going to allocate to the CPU. Okay, at time here, time 11. So P4 will be going to execute at time 11, and according to this one time quantum, it will be going to execute 3 unit of time, and you have to see parallelly what is the time quantum for P4. What is the time quantum for P4? Time quantum for P4 is, see here, see time quantum for burst time of your P4, not time quantum, burst time. Burst time of P4 is 3. So it will be going to execute 3 unit of time. So 11 plus 3 till 14, P4 will be going to execute. P4 will be going to execute. So you can see that while executing 3 burst time, P4 also completing its execution. P4 also completing its execution. So at again 14, time 14, again which is the process in the ready queue, P3. So P3 is going to remove from the ready queue and allocate it to the CPU at time 14. At time 14, P3 is going to allocate to the CPU at time 14. Again, coming back to here, P3's burst time, here it is 4. Okay, it will be going to execute 3 more unit because our time quantum is 3. So 14 plus 3, 17 till 17, P3 will be going to execute. So here see still burst time of process P3, see here it is 4. So we can execute only 3, right? So pending burst time still for P3 is 1, right? So again what will be going to happen? So once it is at time 17, P3 is going to, you can see that P3 is going to insert in your ready queue. P3 is going to insert in your ready queue. P3 at the end of your ready queue, P3 is going to insert in your ready queue because still one more unit P3 has to complete. Okay, next at time 17, which is the first process in your ready queue, it is P5. So P5 is removed from the ready queue and inserting or giving to the CPU. So here CPU is going to execute P5. It has removed from the ready queue and CPU is allocating. Then from 17, P5 will be going to execute 3 more units, and you have to parallelly see what is the burst time of P5. Here it is, burst time is 5. We can execute only how much? 3. So 5 minus 3, 2 is pending. So it will be going to execute 3. So 17 plus 3 till 20, P5 will be going to execute. Again P5 will be come back to your ready queue. P5 will be come back to your ready queue because still 2 more unit it has to execute. Then at time 20, what is the first process in your ready queue? Here it is P1. P1 will be going to remove from the ready queue and allocating to the CPU here. Allocating to the CPU here. Then P1 will be going to execute. What is the pending time of P1 here? See, only 2. Only 2 is the burst time of here in the table. You see, only 2 is the burst time pending. So from here 20 to 22 it will be going to execute. Okay, so up to 22 time P1 is going to complete its execution. So process P1 is going to, here process P1 is going to complete its execution at time 22. Then coming back to your ready queue, what is the next process? It is P3. So P3 is removing from the ready queue and inserting in your NACHA, that is allocating to the CPU at time 22 P3. P3 come back to what is the burst time pending? It is burst time pending for P3 is only 1. Here 1. See, 1 is only pending. So 1 it will be going to execute. So 22 to 23. 23 plus 1. 23 it is going to execute and P3 is going to complete its execution. Next pending is P5 from the ready queue. It is going to allocate to the CPU. P5, what is the remaining burst time it is needed is P5 remaining burst time it is needed is 22 unit of time. So 23 plus 2 again it is 25. So at time 25 P5 is going to complete its execution. So completing your NAT chart here. Then by using, you have completed NAT chart means easy to calculate the value, completion time, turnaround time, waiting time and response time, right? Completion time. So coming to completion time, what is completion time? At what time that process P1 has completed its execution. So you have to check your NAT chart. Say check your NAT chart. What time process P1 has completed? See here. See here, process P1 has completed its execution at what time? 22. Right. So we are writing here process P1 completion time 22. Okay. So next at process P2. Process P2 at what time it has completed its execution? See the process P2 at time 11 here. Time 11 process P2 has completed its execution. Process P3, coming to process P3, when it is completing, here only it is actually completing. See, process P3 has allocated so many different times, 1, 2, 3, but last time only you have to take its completion time. So here this 23 is the completion time of process P3, 23. Next, P4 has completed here. See, P4 has completed here 14. Next, P5, finally P5 has completed here 25. So P5 completion time is 25. Then turnaround time, you know, completion time minus arrival time. Okay, completion time is 22 minus its arrival time 0. 22 minus 0, 22. Here for process P2, 11 minus 5. 11 minus its process P2 completion time is 11 and its arrival time is 5, so it is 6. Like that you calculate, you will get the turnaround time. Then waiting time. What is waiting time? This turnaround time minus burst time. So turnaround time for process P1 is 22 minus its burst time. Starting burst time was 8, so 22 minus 8, 14. Then for process P2, 6 minus turnaround time is 6 minus burst time is 2, 4. Then P3 process P3, 22 minus 7, 15. Like that you will get waiting time. Next, response time. What is response time? What is the time it got CPU minus what is the time it has arrived in the ready queue? That is your response time. See, what is the response? What time it has got CPU P1 time 0, it has got CPU time here. It got CPU time. Process P1 got CPU time at 0 and it has arrived at time 0. So 0 minus 0, 0. Next, for P2, what time P2 got CPU? See here. What time P2 got CPU? See here, at time 9. And what time it arrived in the ready queue? At 5. Right, it has arrived in the ready queue at 5. So 9 minus 5, 4. Like that you will calculate response time. Okay, and average you know how to calculate. Take the sum divided by total number of process 5. So average waiting time is, take the sum of waiting time divided by 5 is equal to 10 you will get. If they are asking for average turnaround time, take the sum of full turnaround time divided by 5 you will get average turnaround time. Okay. So next video we will discuss priority scheduling algorithm. Thank you.